Welcome to the course of structural analysis. In this lecture, we are going to see the topic that is related to the sign convention for shear force and bending moment. So before going to the sign convention, we'll just see the concept of shear force and bending moment also. So coming to the concept of shear force, so when we consider any structural member like a beam, it is subjected to an external load, then some internal force is induced in that structural member in the transverse direction, which is going to cause a transverse deformation. So due to this transverse deformation, that leads to a shear failure, and it is called a shear force. Now coming to the sign convention for a shear force diagram, just consider a cantilever beam AB, which is having a span L, and it is having a point load W at the free end. And due to this fixity, you are having a reaction W at the fixed end, and there is a moment also developed at the A support, that is MA. And now we are taking a section XX from the free end, which is at a distance of X. Now, if you just consider a small segment here in this section, so this is a segment. So for this segment, when we cut a section at this portion, I mean, I have taken a small element here. When we cut a section, towards your left hand side, if you're having an upward arrow, and towards your right hand side, if you're having a downward arrow, that means towards this section, if you just consider this left hand side or a right hand side reaction, it is coming in a clockwise direction. So for this clockwise, you are considering the shear force direction to be positive. So this one we'll call it as a positive shear. And similarly, when we consider another example like simply supported beam, which is having a span of L, and you're having a point load at the center. Therefore, due to the symmetry, it is that is center point load. Therefore, it is equidistant, that is L by 2 and L by 2. So due to this symmetry, you're having a reactions at A and B to be W by 2 and W by 2. Now, if you just consider a section XX, at B, you are having taking a section X to this XX section. Now, if you just consider a small element here, so this is a small element. So towards your left hand side, if it is downward arrow, and towards your right hand side, it is an upward arrow. So towards this section, if you just consider these two arrows, so both are going in the anti-clockwise direction. Therefore, the shear here, it is negative shear. So this is a negative shear. So by using these sign conventions, we are going to solve the one example. So before solving that, we'll go for a definition for the shear force. So shear force is nothing but any section if you just cut for a structural member, it is equal to the algebraic sum of your transverse loads. So here the transverse loads means at that section when we cut, so the summation of both the external loads as well as the support reactions at the either section of the side of the section is going to be considered. Now, example, if you just take a cantilever beam. So this is a cantilever beam I have taken, so which is having a section X from the free end. So now the sign convention here, it is a positive shear which is of clockwise direction, and this is a negative shear which is of anti-clockwise direction. Now, when we write a shear force at this XX section, so towards your right hand side, the arrow is downward, and which is also in the clockwise direction. So it is a positive. So shear force at XX will be equal to plus W, which is of a limit 0 is less than or equal to X is less than or equal to L. Why? Because here in this entire beam, you're having only load at the free end. There is no other load at the in this beam. Therefore, one section is sufficient. Therefore, X is equal to 0, you're having W, and as well as X is equal to L, you're having a W. So both are positive only. So both are on the same side. So it is a positive shear force diagram. Now, when we consider another example, that is a simply supported beam. So for this simply supported beam, you're having a central point load. So as you're dividing the beam into two segments, so you're going to take two sections, that is X1 section in BC segment and x2 section in your AC segment. So now we'll see the sign convention, same positive shear, which is of clockwise direction towards the section, and negative shear, anti-clockwise direction towards the section. Now bending shear force at this x section when we given by. So first section you're going to consider. So here it is in the anti-clockwise direction from this B support. Therefore, it is minus W by 2. And it is of limit from 0 to L by 2. Therefore, another section we just cut it in a CS segment. So towards this CS segment, you have to add the externally applied load as well as your support reaction. So here the support reaction is W by 2, which is in anti-clockwise direction, therefore negative. And this externally applied load is plus W. Why? Because it is in the clockwise direction. Therefore, minus W by 2 plus W. So total you are getting it as plus W by 2. And the limits here are L by 2 to L. So now if you just consider in this BC segment, you are getting minus W by 2, and the CA segment, you are getting plus W by 2. So if you just see the shear force diagram, at B minus W by 2, at C minus W by 2. So this is negative 1. And from C to A, you're having a positive value of plus W by 2 from C to A. So this is a final resultant shear force diagram for this simply supported beam. Now coming to the next concept, that is your bending moment. So when any structural member we are going to consider like beam, it is subjected to an external load. Then the internal moment that is going to induce in this structural member, it is going to cause a rotational deformation. So rotational deformation means that is going to be theta-like. So that leads to a flexural failure, and it is called a bending moment. Now moving on to the sign convention for bending moment. Same like we consider a cantilever beam AB, which is having a length L, and the externally applied load is W at the free end. Therefore, at the fixed end, you are going to have a reaction like W in the opposite direction, and the moment is also going to develop at the fixed supported A. When we cut a section at this portion, which is at a distance of X from the free end, now you just see this is a negative shear force. We can call this as a hogging moment also. So towards the section, when the arrows are heading downwards, that means you can also say that towards your right hand side of your section, if the moment is in the clockwise direction, and towards left hand side of your direction, when the moment is in the anti-clockwise direction, whatever the bending moment that is going to be developed is your negative value. So this one we'll call it as a hogging moment, or you can call it as a negative moment also. Now coming to the next example, simply supported beam. So which is having a span L and a central point load that is W, which is at a equidistant from both the supports A and B. Now and due to this equidistant, central load, so due to this symmetric portion, you're going to develop a reaction set A and B will be W by 2 and W by 2. Now when we cut a section here, which is at a distance of X from the B support. So when the arrows are heading upwards towards the section, so it will be a positive value. So that means when we consider a section and towards the right hand side, if the moment developed is in anti-clockwise direction, and towards left hand side direction, when the moment developed is in the clockwise direction. So here you are going to get the positive moment, and this moment we'll call it as a sagging moment. And this is a sign convention. Now we'll see the definition of a bending moment diagram. Bending moment. So bending moment is nothing but at any section of a structural member, if we just consider, it is equal to the algebraic sum of all the moments that are come due to the transverse loads. So here the transverse loads are nothing but the external loads and your support reactions at either side of the section that is going to be considered. So now example, if you just consider the same cantilever beam, which is having at X distance from the free support. So the sign convention here is, this is a sagging moment and this is a hogging moment. Now, when we write a bending moment at this section, so towards the right hand side, your W is in the downward arrow headed direction towards the section, and it is also in the clockwise direction. Therefore, it is a negative minus W into X. And the limit here is 0 to L. So at x is equal to 0, you are having the moment to be 0. And at x is equal to L, your moment will be negative WL. So therefore, the bending moment here, the representation is 0 at the B support and WL will at the A support. And this is of the negative value. So this is a negative bending moment diagram for a cantilever beam. And next example, if you just consider same like a simply supported beam. So the load is dividing. So it is having a two sections. So the sign convention same, sagging as well as hogging moments if you just consider. Now bending moment at this sections when we write. So first section XX if you consider. So at the B support you are having a reaction upward, and the moment is also heading towards upward arrow towards this X1 section. So which is also in anti-clockwise direction at this section. So it is plus W by 2 into X, and the limits here are 0 to L by 2. So at X is equal to 0, the moment is 0, that is at B. And at X is equal to L by 2, that is at C, it is WL by 4. Now again, when we consider another section X2 in this CA segment, now the bending moment equation is here W by 2 is an upward, so which is in sagging nature. Therefore, W by 2 into X plus, this is in plus direction, and this plus W here, whatever the load, it is in downward and it is also in clockwise direction. So towards the section, if it is in the clockwise direction, in your right hand side, it is a negative value. So therefore, it is minus W into, so this distance you have to write. So that is X minus L by 2. So this is from the limit of L by 2 to L. So when you substitute X is equal to L by 2, so bending moment at this C portion will be equal to WL by 4, whereas at X is equal to L, that is at the A, you are having bending moment to be 0. So now when we see here, A and B are having 0 moments. At C, you are having WL by 4. So which is of positive value. So this is a positive bending moment diagram. So this is how we are going to draw the shear force and bending moment diagram with the sign conventions. So these are the textbooks and references. Thank you.